Hi, my name is Dave Farina, and this is my video for Module 1 of ACTE 651 Science Curriculum and Reform for Summer 1 of 2016 at Millersville University. I am a teacher at Manheim Township High School in Lancaster, Pennsylvania. I teach in the science department. I teach the following courses: Astronomy, the Sky and the Stars, Astronomy, the Solar System and the Universe, Geology, Oceanography, Meteorology, Environment and Ecology, ninth grade Physical Science, and as of this year, an independent study where I have a student who is working on producing planetarium shows, for which he's already given a number of public showings, as well as studying astrophysics and doing telescopic observations through our telescopes. I'm also the advisor for the Manheim Township Astronomy Club. I'm also the director of the Manheim Township Planetarium. I don't have it on the list here, but I am chaperone to the Manheim Township Ski Club, and also I am the science person for the Eco Club if they need help. Why STEM? Why pursue the STEM endorsement? Personal interest mostly is my reason, but in addition to that, I do want to learn the best practices, become a better teacher in STEM specifically. I also have some interest in an alternative path in my job and career as a tech ed department person. I may seek a tech ed certification at some point. My educational background, I have a bachelor's in Earth and Space Science education with a concentration in geology from Kutztown University. I also hold a master's degree in geosciences from Westchester University and have an additional 30 credits, mostly from Westchester, a few from Millersville, beyond my master's degree. I did start the technology certification here, technology education program here, and I am now in the STEM certification program, for which this class is the first of. My home life, I am married to my beautiful wife, Missy. She's a teacher at Hamburg Area School District in PA. We've been married approximately 5 years, and she still puts up with me, so that's a good thing. We are both nerds, and that's also a good thing. We have 2 cats. We have a fat cat and a skinny cat. The fat cat is named CERN after the Large Hadron Collider in Switzerland, France. And he's the scaredy cat. And then there's also Nittany. We're Penn State fans, so he's the Curiosity Killed the Cat. And at some point in the near future, we hope to start a family. My hobbies, I have an interest in astronomy, as you may already have found out. I am the club president of Astronomy Enthusiasts of Lancaster County. We do public outreach, we do star watches, we do lectures, and our website is aelc.us if you're interested in coming out sometime. I'm also interested in astrophotography, landscapes, macro photography. A Jet Propulsions Lab and NASA Solar System Ambassador. I do like public outreach for that. And I'm also interested in snowboarding, hiking, camping, kayaking, just being outdoors when I can get the chance without being locked in my classroom. Here's a picture of a nightscape with the Milky Way in the background. This is from when I was out west this past summer. These are the types of cool things I can bring back to my students and use these as teaching tools. For instance, here the Milky Way with dust and gas going through the center of it. Here's a picture of the moon. We talk about the craters and cratering processes, the maria, which are floodplains on the surface. We also have here a picture of a nightscape with the constellation Orion, and the 3 stars in the center of the picture are, of course, Orion's belt. Just below that is the Orion Nebula, a star-forming region where stars are being formed right now. You can also see it in the right behind the trees there is a bunch of light pollution, which is a bad thing for astronomy. Here we have M13, which is a globular cluster, and there are tens of thousands, if not hundreds of thousands of stars in this one picture. We also have the Dumbbell Nebula. The Dumbbell Nebula is a supernova remnant, and you can actually see if you look in the center of the picture, there is a line, and that line in the center of the dumbbell is actually the shock wave from the supernova passing through it. So these are, once again, the types of cool pictures that we can take through our telescope. This is with my camera through a telescope, and students actually have the opportunity to do these types of things in my class. I do travel. I plan to travel to all the national parks at some point. This past summer, I got an awesome experience. I took a trip out west with the Geology of National Parks trip through Westchester University and was able to visit Yellowstone and also the Grand Teton National Park, which was a really neat experience. Here's a picture I took over Jenny Lake with the Grand Teton in the back, and just a breathtaking image, awe-inspiring for me just to remember this awesome picture. Here's a picture once again over Jenny Lake with some macro photography with the background blurred out. Kind of cool to talk about focal lengths, and can talk all about pictures. Here's a picture of me with a geologic feature called the goose egg. This is one part of the goose egg. The goose egg is a very large area where geologists are tested in the field. It's their final exam. So this was me taking some readings. You can see in my hand a little Brunton compass and my field notebook. This was a really hot day, so I look pretty tired at this point. How would I describe my STEM perspective? It's pretty much all over the place. If this were a concept map, you can tell that it's pretty much any direction my mind goes is where I go. Why is it important to increase STEM literacy, even for those who will not pursue STEM careers? I feel that this is very important because in the future, people are going to need, and even now, people are going to need to have a STEM understanding to get a career, whether that job, as it says here, 16 out of 20 future jobs will require some sort of STEM component, even if they are not needing an advanced degree. Only 4 out of 20 are going to require an advanced degree. Personal decision making will require the incorporation of STEM principles. For instance, medical care might require you to think about what you know about STEM in order to make a good informed decision. Policy decisions, things like that. Increased need for lifelong STEM learning to keep up with global trends. You know, the rest of the world is moving forward, and we need to keep up. STEM-based practices seem to be the best way or best criteria to measure success. There are some challenges due to the fact that we have uncontrolled variables in a school. When taking social data, this is always a problem. It's hard to disentangle, the article said, from other effects in the school. You know, poverty levels, just where these kids are coming from is hard to tell. Upcoming longitudinal studies are going to help this significantly, and big data is going to help significantly. What attributes are going to be we're going to mean a program is successful. Successful programs are going to rely on dedicated teachers with strong administration. That administration part is key. Can't get anywhere without that. Creation of teacher professional learning communities or peer-to-peer mentorship is really awesome as well. What educational practices do successful programs employ? From everything I could tell, and I also did this in my last class as well, project-based assessment really seems to be the method or process that's used in order to help students the most. And this seems to be across the board. And if you can incorporate with this a real world experience, it's even better. So what can schools do to support STEM education? You can first consider setting up a teacher STEM mentoring program. Second, take a serious look at all the different program types. Single discipline, STEM as a reference for science and math. The one I think I'm most close to, which is separate science disciplines that incorporate other disciplines within them. Separate disciplines completely. Science and math connected by technology and engineering. And finally, coordination across disciplines, which is probably the most challenging in my opinion at the high school level. At middle school, it makes a lot more sense with teams. What do I do in my classroom to incorporate STEM? I think I do my best already. I would like to try to figure out how to make things even more cohesive. And once again, I think I fit into the category of the separate sciences that incorporate other disciplines. So, for instance, I have some paper making. We've got some wind turbines that I made from the lab stands, ring stands. We've got some students that are working on the effect of radiation on different color objects. We've got my Walter White wannabe. We've got, this is really neat. We just got this telescope. It's capable of doing astrophotography and spectrophotometry, so taking light and separating it into its spectrum. And then from that, you can get all sorts of information about stars and planets and comets, what they're made of, how fast are they going. It's amazing. It's all computer controlled, robotics. Students run this. It's really kind of cool to watch. We just also got this, which is a virtual reality camera. It shoots in 4K video. This was through some fundraising by my astronomy club, actually. And this last one was actually a grant. So my school's not spending money on this. The bottom of the telescope, the tripod and mount, is fundraised money from my club. The top part of the mount is mostly a grant. I'll just show this short video. So we made a robot that was capable of going into the pool. It's part of the Flexi program from MIT. So this was actually two young ladies who took advantage of the opportunity and made this robot, and it's remotely controlled by them from above the pool. I have my students do a final project rather than a final exam that incorporates all of the things they learned in my class. We do some field work out in the field. We bring some information from the field back in. We do things like stream studies. We make crystals. We run planetarium shows. This is some star trails in the planetarium. We do star watches. This is the transit of Venus, where we watch Venus cross over in front of the sun. Once again, some students out in the field, this time doing some surveying and soil studies. Here are some students in my lab, some 9th graders that are working on an indicator study to look for pH. Here are an experiment where students are looking at the angle of incoming solar radiation and the effect on temperature. Here are some of my astronomy club students, and the one on the left, Ross, and the one on the right is Anya, and they were working on planetarium shows for the public. And here is some of Ross's planetarium show, where he was presenting. Here's some of my astronomy club students outside looking through solar telescopes. We bring some arts into this also with a galactic art, Bert Alicio. My goals for the course, I hope to try to take the course and hone my skills as a practitioner, polish my current best practices, make connections, and obtain that STEM certification. I hope you all enjoyed my video. Thank you very much.